Hey, I think I'm on air now. Great to be back at one of our famous Brainfood Talks, I would already say. I would call this format already. So I think it's for me the third time that I have the opportunity to share some thoughts here. And I'm always happy when people ask me if I have some content which I can bring on our internal, external knowledge sharing format, right? So today I will talk a little bit about platform engineering. I would say not one of these topics where most of you maybe do not connect me with, but I think it's one of the topics which got a lot of interest for me over the last couple of months or even years. And I would like to talk a little bit about this topic as it's currently very vibrant in our community. Lots of people talk about platform engineering. I think it's even a Gartner hype cycle, right? And this means something, obviously. And that's why I framed this talk. Platform engineering is not what you think it is, because I would like to explain a little bit why I think that we are maybe moving into this, anti-pattern of our industry, to misunderstand things, and to have a better understanding what platform engineering really is about, and why it can be useful, or why it can, I think, even be a game changer in the way how we build software these days. So I would say, let's jump over to the slides, because first things first, I would quickly like to introduce myself to those who do not know me. I'm David. I'm a principal engineer at a company called Square. I shifted my focus over the last couple of months a little bit from Vienna to Munich. That's why I'm probably not that present anymore at the Viennese community, but I do a couple of stuff in Munich these days. And I'm always happy to kind of share my thoughts, get feedback on those thoughts. That's why I'm also here today. So if you have any questions, feel free always to ask them. I will try to answer all of them at the end of this presentation. And if not today, then you find me with this email address and with this short name, basically, with this alias all around the internet. And before we jump deeply into platform engineering, I think it's always super important to actually understand where these things are coming from. And I strongly believe if you do not know where things are coming from, you have a hard time in understanding why those things are useful. And for platform engineering, basically for everything in our industry, this is particularly true. And platform engineering comes, or let's maybe start the journey at the very beginning, right? So a long time ago, we had this so-called BBC architectures, right? So everything basically followed the BBC architecture, saying that everything consists of a box connected to a box connected to a cylinder. This was the universal architecture, and it was coined by a guy called Ted Neward. And the funny coincidence is that we had Ted Neward just a couple of weeks ago in our podcast, which we also do at Square, and talked exactly about the BBC architecture, right? Just to give the credits to those people who basically invented this fantastic term. But it's kind of funny because back then, really everything seemed to be a BBC architecture, right? Every whiteboard image of an architecture looked at a certain abstraction level, basically like this. And this is what we tended to call an horizontal architecture, of course. And the thing with software in general, right? Software eats the world. We're building tons of software each day. So this is why these horizontal architectures really, got up to the name and grew a lot horizontally. Right. And the initial idea in our industry was usually to, kind of structure those horizontal architectures based on technical means. And yeah, according to Melvin Conway, and we know Melvin is always right, we also had organizational structures to this, which actually led to these architectures. Right? We had people who were deeply into operations and databases. We had people who were deeply into backend engineering and maybe some mainframe engineering back in the days. And we had people who were mainly about, customer facing channels or just front-end UI implementations. And the problem of this is, of course, fast forward quite clear these days that if you wanted to change something across the user journey, then you basically had the issue that you need to touch all those things and need to touch all those teams. Right? And this made us, of course, slow. This made us slow in our pace, how we can deliver software. This made us slow in cycle times. This made us slow in reacting to market needs. And that's why, of course, I would say this biggest shift in our industry when it comes to software architecture or in software development in general, and also to organizational structures, is, of course, that we shifted this around and said, okay, no, we don't want to have those horizontal teams, those teams driven by technical means. We want to have those vertical teams, teams driven by customer journeys, teams that can independently deliver customer value. And of course, this whole area is a topic on its own, and I did a couple of presentations covering this in more detail. But I think it's quite important that we understand there was this shift, right? There was this shift to say, okay, this team owns product search, this team owns checkouts and payments, this team owns delivery and tracking, and this team owns warehouse management. And by giving those teams the high autonomy, not only from a context and a business perspective, and giving them ownership of their own domain, and also, with microservices and all those social technical architectural styles we introduced over the last couple of years, we basically had this promise that we give them high autonomy, because high autonomy means high pace. Right? That's the whole idea, and that's the whole idea of, I think, what we do in the last couple of decade in our industry, to ensure that our organizations, our architecture, everything follows those principles, that teams can highly autonomously work on things, can highly autonomously build and deliver things. Werner Vogel's famous, you build it, you run it, right? And thereby we get high pace in our engineering organization, right? So high autonomy, that's the important term there. And we talk about this a lot, right? And I took this slide from Sam Newman, basically the inspiration of this slide, because he also uses this background in his slides quite often. And I like the film, I guess, as much as he does. But I have the feeling that with autonomy, we have the same situation, right? We keep using this word without fully understanding what we basically mean by it. Probably we understand what we mean by it, but we do not understand the trade-offs of autonomy. And I realize this especially as I work with a lot of teams, that these days are pushing heavily for autonomy. They want to have more autonomy. They want to have more freedom. They want to land in this, beautiful, drafted, microservice, self-sufficient team land, where they basically can do stuff on their own and where they can take ownership. And that's exactly the thing, right? Autonomy is not a one axis thing. Autonomy is always in relation to responsibility or accountability, we could say. And what's important about autonomy and responsibility is that they are in a fair condition to each other. So this is this blue line, because if you're not in this blue line, let's say you give the teams a lot of autonomy, but zero responsibility, so they can select whatever they want to do in terms of programming languages, frameworks. They can drive heavily how implementations look like, but they don't take ownership of this. They don't take, in the end, responsibility or accountability. Then you're in this zone of ops will hate you, right? And ops will probably quit you, right? Because they have exactly those issues, those companies where teams start to be very autonomous, but don't have, the framework, the structure to take responsibility. And then they just throw it over the line again, and somebody else needs to take care of this. And then you kind of need to cover services with 20 different languages and frameworks, which is of course not fun, right? If you do it the other way around, right, which we also often see, to say, hey, these teams shift left, these teams need to take more responsibility, more accountability. And this is where the devs will probably quit you, right? They say, yeah, we are able to take accountability and responsibility, but we are not able if we don't have zero autonomy, right? We're not able to do so if, enterprise architecture tells us to every bit and piece how we need to implement things, right? If, we have no choice on technology at all, if we just use the default thing for everything, and we just break our fingers by doing so. And of course, this accelerated. The point I want to make is that it's really important that you stay along those blue lines. And I don't say that you need to do, you build it, you run it, right? That you build it, you run it basically says it, right? You have full autonomy in whatever you do, but you also have full responsibility and accountability for whatever you're doing, right? And this is again, a long discussion if you go into this direction or not. But obviously, you should stay somewhere around this blue line. Maybe you build it, you own it, or you build it, you care. Whatever you ultimately do and whatever you ultimately fits into your organization, I think is important to do. And this basically means that high autonomy doesn't automatically come with high pace. it probably comes with high pace if you have high responsibility and accountability within the teams. And I think this is what we also seen in another part of our industry, right? Especially the DevOps movement. If we say we always had, this strict governance usually, where it was very hard for teams to kind of spin up infrastructure, to kind of, do things how they would like to do it. And we shifted, of course, from this, central operations, design authorities, technology boards, all the things. We said, okay, no, we don't care about this anymore. The team should get autonomy to do this on their own, and you basically are in this ability to run it mode, right? Or as I said before, you can make this a little bit more into the middle to say, okay, you build it, you own it, we run it for you, but of course then we need to enforce more governance, then we need to have more standards, because otherwise this collaboration will not work, right? So again, I'm not saying that you should go into one of these directions. I just say that it's very important to make this explicit and transparent to the teams, what you expect from them and whatnot. And this whole full autonomy thing is usually what we tend to call shift left in our industry, right? We do this all the time. If you think about software engineering, shifting left, right? We started with JUnit or XUnit a couple of decades ago these days and said, okay, you are responsible to write the tests, right? And then we did kind of, Gherkins and behavior-driven development and said, hey, you are responsible to kind of ensure that the requirements are properly reflected in the software code. And we do this with DevOps and say, hey, you as a dev team are responsible to run your stuff, right? So shift left is nothing new, right? But the term got momentum and I like it. But the idea is basically in our industry with cloud native infrastructure now to say, okay, we take all this and we don't have a central department anymore taking care of this, but shift it left into the teams, right? And we all know how the cloud native landscape looks these days, right? And you can of course say, okay, we don't do this centrally anymore, but we shift it left to the teams. But this is what I usually tend to call then, it's not a shift left anymore, it's probably a pie left, right? And it's just usually a pain in years for a team to kind of be able to overview all the things which are happening there, having, an understanding about what are the right tools and the right products to use, and ultimately leading to kind of, a complete technology mess in that sense, that you have a lot of tools laying around, which are, just operated by a handful of people who have deep understanding how this does work, and you have a lot of duplication in that sense that you have, various tools for, I would say, at least similar use cases. So I think it's very, very unrealistic if you again jump back to this cloud native infrastructure landscape to say we can shift left all this stuff, right? This is way too complex. This is bloating the cognitive load of a team if you tell them, you build it, you run it, here's the cloud native landscape, do your stuff, right? So this is where we usually then end up in this shift left, or in this paradigm. I say, okay, if you want to have full autonomy, you at some point in time also end up with the speed paradox, right? Where we say, okay, if everybody is doing everything, right, we end up in this good old wet principle. We write everything twice, right? We enjoy typing or waste everyone's time. So this cannot be the answer, right? Full autonomy, which we often hear people preaching, cannot be the answer, obviously, right? Because there needs to be a middle ground, right? And on the other hand, if you have strict governance, you have this standard paradox where you see, okay, things are actually, constraints are basically driving organizations to get faster if you put the right constraints. So as always, of course, we should be somewhere in the middle. And this is what we tend to call in our industry the last couple of years, the golden path or the path path, however we call it. But we want to provide, something which is kind of, standardized, which you can easily follow, but also doesn't force you to follow it, right? So you can still have this autonomy, which probably leads to the speed paradox that if you do not kind of, follow some golden paths within an organization, you will end up slowly. But that's the whole idea of this concept, right? To bring something up where we say, hey, this is a good middle ground, for the full autonomy and standard paradox. And of course, a couple of people in our industries have observed this movement, which I tried to show you in the last couple of 10 minutes, right, from various angles. And of course, one of those, I would say, communities in our industry is the DevOps community. And this is actually also where those guys originate from. So the guys behind the book Team Topologies, Matthew Skelton and Manuel Pace, who wrote this masterpiece a few years ago. And they basically figured a very similar thing out, right? They said, okay, yeah, we have these, distributed systems these days. I don't even dare to call them microservices anymore, but, something that is distributed so that basically teams can take ownership of it, right? And we usually do this verticalized, right? So we have teams taking care of things and we have them verticalized, or order a product, perform a payment, or execute a delivery, something that is tangible, that brings customer value. And we basically give those teams autonomy to do so, right? And we give them end-to-end responsibility, right? We figured out the more breaks we have in the customer journey across teams, the longer it will take us, the more latency we get in, right? And by the way, that's also one of the advices I always give. If you challenge your architecture, right, really understand how many hops do you need to kind of fulfill a customer journey, to fulfill a customer need. And I think you can do the same thing with teams. How many teams do you need to involve to kind of add a new payment provider? How many teams do you need to involve to basically change a little bit your checkout process, right? If this number is getting too big, you probably should rethink your slicing. Probably, right? And say that it's always wrong, but of course that's an indicator which I think is very, very useful, because that's what we're optimizing for, right? High team autonomy so that teams can take as much as possible end-to-end responsibility. And of course, there's a problem, right? That's what I tried to say in the previous slides. Also, there's a problem in verticalize all the things. And this is the cognitive load, of course, right? So ordering a product or maybe performing a payment, right? And I've worked a lot in financial industries. Yeah, if you say, okay, you as a team own the complete story to transfer money via an IBAN from one user to another, or from one account to another, starting with the mobile application and the Angular web banking application, going down, backwards to the mainframe, right? Of course, this is nothing which a team in a useful size could fulfill, right? They would just say, okay, that's too much, right? On the technical side, but probably also on the business side, on a domain side, to I don't know, fraud validations and things like this. This cannot all live in one team, and that's basically the idea of team topologies, to say we don't only have these verticalized, stream-aligned teams, but we should also basically have different teams. And those different teams now come in various shapes and names. And one of them, for example, is the enabling team, right? So the guys from team topologies come up with 4 team types, right? And one of the enabling team, we will not talk about this too much in this talk today, but it's basically the consulting team, right? Having the goal to enable those teams, I don't know, in technologies, if they start to use Kafka but have no clue about Kafka, then those teams help them, to get onboarded, to gain the knowledge, always with the goal to make themselves obsolete, so that they can move on to other teams. And then we have this complex subsystem team, right? Good example would have been the core banking system I named before, to say, okay, there is a system which itself is so complicated or even complex that if we put it into a single team, this single team would be, kind of completely bloated by just a single system. So let's take it out. Let's say, okay, we have a separate team for core banking system, right? Also, it doesn't fulfill our verticalization. It's kind of a horizontal layer again. But, this team has a clear boundary. This team is basically there to, again, make the life for the stream-aligned teams easier, so that they can focus on other things and, kind of keep this as a black box, which with well integration points in the back of the head. And then last but not least, the last team which came out of this book was platform teams, right? And this is what we will talk about today. And I have to say why I like this book so much, and why I kind of quote it so often, is because I think this book does something which we rarely have in our industry, and introducing a pattern language, very well-defined pattern language of the teams we have in our industry. And we had these teams before this book existed, right? But this book made something very important to us. It gave us a common naming, right? It gave us an understanding how we could basically think about the teams we have in our organization, and which constraints we should put on these teams. Right? And that's, I think, why it's very useful to talk about, of course, a very abstracted way again, but I think we have this language. People usually know, since these books exist, what you mean by a complex subsystem team, what you mean by a streamlined team, what you mean by an enabling or platform team. So let's quickly talk about platform teams. And platform teams can be everything. They cannot be only the part which I will focus on today's talk about, but they can be, kind of those teams which, first of all, ensure that the cognitive load of those streamlined teams decreases, and they can do this in various ways. For example, an IoT hub, right? So you work in industry where you have kind of a lot of IoT access. IoT hub would be a perfect platform team because you say, hey, I abstract away the integration to IoTs. You can focus on your customer journeys, and I'm here, the platform team, to basically provide the streamlined teams a platform how they can easily integrate with IoTs. Right? And that's the important part here. Platform teams are product teams, and they build a product, and the customer of this product is the developer in the streamlined teams. We'll talk about this later again. I just wanted to mention it already because I think it's so important. And then we have, of course, design system could also be a platform, right? So everything that basically helps reducing the cognitive load in the streamlined teams could be a platform. But today I will mainly talk about, of course, about internal developer platforms, right? IDPs, yeah, perfect acronym in our industry. It's not confusing at all. But in that case, it stands for internal developer platform, right? And not identity provider. Yeah, just for those who didn't get the joke so far. And the thing about Intel developer platforms is they got really popular these days, right? And you see that they got popular these days because they have their own logo and they have their own website. And the website is not bad at all. It really gives, I think, a very, very good description what Intel developer platforms are doing, what problem they try to solve, and maybe even a little bit how they can be implemented. And still, if the website is good, I still like the quote from Evan Potcher from ThoughtWorks the most when it comes to platforms, because he says a platform is a foundation of self-service APIs. Yeah, very important. We'll talk about this in a second. Tools and services, knowledge and support, which are arranged as a compelling internal product, right? So basically what I also said before, it's about building products, and the audience of these products are the autonomous delivery teams that can make use of the platform to deliver product features at a higher pace. So if you see yourself in a platform team, your main goal is basically to decrease cognitive load in the streamlined team so that they can deliver their stuff faster at a higher pace, right? To deliver value faster. And if you're not doing a good job in this, right, and if teams do not want to use your platform, then you should probably rethink again. If you do kind of good product engineering in the first place to figure out, hey, what is the need of this platform? What is really the pain of developers? How can we help them in the teams that they can focus on the important stuff, and we can take a lot of load from the shoulders. And when we talk a little bit about the technical things now, right? Then I think it's important to mention that platforms are mainly about abstractions and not about composition, right? And this sounds now a little bit strange, right? Composition, abstraction, okay, yeah, sounds a little bit like the same thing. So what do I mean by this, right? So let's take the simple example of a team wanting to deploy a microservice, right? So if you as a team these days want to deploy a microservice, it's rather straightforward, right? You deploy a pod. Well, you do not deploy a pod, you deploy a namespace first and an autoscaler. You just deploy a deployment, right? And then you also need to ensure that you have a database and you have to write schemas and tables in place. And you basically probably need a Kafka topic. Everybody needs a Kafka topic, right? And you basically need some alerts and some monitoring. So you have some Datadog frameworks and stuff like this, or some Dynatrace stuff. And you basically have probably some kind of read models or any kind of other things, an Elasticsearch cluster, for example, right? And of course, you cannot really expect from a single team that it does all those things and it does it properly and does it right? So you could do, but yeah, you probably will have a team which is coming very soon, the bottleneck, to always help those teams to doing that, right? And our option would, of course, be to build a platform in terms of, the good old Jira platform, where you put in a ticket and somebody does all this stuff for you. But of course, this is not what we want to do usually, right? We want to do it in a different way. We want to kind of ensure that this is more in an automated manner. And you would then, in the worst case, need to put a ticket for each of those things we need, right? We all know what I'm talking about. We all have been there. And basically, you have the big problem. It doesn't matter if you have this platform Jira, right? I just took Jira because it creates a lot of emotions usually, or somewhere else. That the problem about this abstraction is, of course, that it's infrastructure centric. So that we focus on the infrastructure. The developer needs to know all these things. He needs to know, okay, I need to create a pod, or she needs to know that I create a table in a database. She or he needs to know all those things. And that's, of course, annoying, right? So we actually want to do this the other way around, right? We want to make this application centric, right? The application centricity should not live in the head of the developer, that he knows how he kind of translates his need of deploying a microservice into infrastructure composition, but to say, okay, the platform should actually provide me, a layer where I say I want to have a microservice, right? And the rest is happening beyond the useful abstraction. Right? And that's what I meant by building application centric abstractions, and not ensuring that you can compose the infrastructure which you need. Right? And that's what it basically is about when we talk about platform engineering. And one good thing we observed by doing this over the last couple of years is that in the initial times when we built those platforms, right, where we had these issues with microservice back in the days very early, that of course you needed to support teams, how to spin up a microservice, how to spin up an ingress, how to spin up all those things, right? With these wrong abstractions of just abstracting the infrastructure and not abstracting the application need, we always ended up in this, kind of sinking platform. How Georg Hope tries to usually name it, where you usually don't build platforms, on bare bone. You build them on top of other platforms, and if you kind of just follow these abstractions of very technical details, but not your application needs within your organization, you usually end up in the sinking platform, and you want to, of course, end up in this floating platform. And if you find this right abstraction to saying, hey, I don't tell you that you need to create a deployment or a Kafka topic or a pod in the worst case. I tell you, hey, you need to create an application. And we take care in the background that we translate this to whatever currently fits our infrastructure to deploy a microservice or whatever you need, right? And this application centricity is super important, right? This is the whole idea, right? We build an API for the developers, right? And this API for the developers should not be the API which we would expect as DevOps engineers, but it's something what they expect, right? Where we again can come up with this infrastructural deployment patterns to say, hey, what are usual the things we do, right? In 80% of our cases, a microservice looks like a Spring Boot application containing a Postgres database, right? And maybe having a connection to an external gateway, and maybe kind of consuming one or two topics from Kafka, right? If we know this, right, we can build fantastic abstractions that abstract all the underlying infrastructure layer away in a way that it's application centric, right? And again, follow the golden path. It will not always work, but if it works in 80% of the use cases, and if you have an extra loop for the other 20%, then you did a great job already. And as I want to really go a little bit more into technical details how we do this, I would like to show an example, I think, how this idea of building application-centric abstractions for your underlying infrastructure can really be realized in a very nice and useful manner. And this is where we talk about operators. So operators is a nice term. I like it. It's a perfect naming, very rare in our industry, because it exactly explains what the thing is about, right? And we're not talking about those operators, which basically take your Jira tickets, and translate them to some infrastructure request or some infrastructure resource, we talk about Kubernetes operators, right? And I like the name because they are basically there to do the same thing. And I see a lot of descriptions of operators and what they are doing, and 2,500 words just to understand what an operator is. But it's basically this one, right? It's a thing sitting in your infrastructure, which basically ensures that whatever you do in terms of your infrastructure as code is kind of ensured within your cluster. And in Kubernetes, this works in a way that you have your resource definition somewhere in a Git repo, you have your Argo or your other kind of pull-based CD, like Flux, that kind of consumes this information. We put this to ECD, and then we basically have operators which are kind of watching this ECD, and based on custom resource definitions, you can even build your own operators that then, for example, ensure that if you want to have a Kubernetes, if you want to have a Postgres table, then it, for example, sets up a Postgres database or just registers a table in an existing database cluster, whatever it takes, right? The idea is really very simple. The idea is that you say, okay, you have something running in your infrastructure, watching what is actually needed and ensuring that it's there. Right? So what an operator does, right? That's why I like this term. And the default operators in Kubernetes are usually called controllers, but it's basically the same thing. They follow the same concept. And you can use operators to kind of, not only do things within the cluster, but of course also do them outside of the cluster, right? I will show an example where we do this, where we did this in the past to say, we create a custom resource definition. So this is our way to extend Kubernetes. We deploy our own operator into Kubernetes, and based on this resource definition, we then, for example, have a resource definition to create a monitor and Datadog. Right? And most of the prominent products these days come with their own operators, so you can actually use them or in the background call them. But that's the whole idea of operators. So not too much complexity there. And what's important is operators rely on these custom resource definitions, right? And the whole idea is that you can extend your Kubernetes cluster with custom resource definitions, which say, hey, this is how a resource which I suddenly start to know looks like, right? It has those fields, it has this type, and I deploy an operator into my Kubernetes cluster, which is a way of ensuring that these resources then really running. And there's a couple of ways to build this. I will not go too much into the way of, coding now the operator. And there's a lot of content from our side already. A colleague of mine, or a couple of colleagues of mine these days actually have intensive knowledge about this, how to use operators and how to build them hands-on for platform engineering. But there is also a lot of stuff we can use out of the box. So it's not always that you need to code your operator with Go or with Java or with whatever you want, right? Basically, you can do it in almost all languages, even Ansible, right? But in many cases, you can even do a more lightweight approach, because remember, the whole idea of these operators is basically not just doing the technical nice thing to spin up a database or a table somewhere. It's more about ensuring that you find the right abstraction so that these developers can provide this custom resource definition in a way that is useful to them. And one way to do this, for example, is cross-plane or also kubevela. And we will talk about both of them, but kubevela I like a lot because it comes up with this idea of the open application model, right? Just another standard, and you all know this this meme about standards, or about the 17 standards. But I like at least that these guys are trying to figure out an application-centric model that helps us to deploy things. And I would not go too much into details now, but the open application model basically consists of components. In that case, for example, the component is a front end, and in that case, it would be a backend. So you basically have, more the application developer-centric view on those things. And then you can add trails to those components. You can say, hey, I want to have an ingress, so I want to have it available from the outside. I want to have an autoscaler. I want to have a couple of more things. So you can look this up on the open application model itself, which is basically driven by the kubevela project, but itself is independently. And you can basically start to do this, and then basically define in your app configuration. You want to have a front end, you want to have a back end, and this is basically then in that case the application configuration. So in the background, it's just custom resources for Kubernetes, but they, I think, give a very good, I would say, at least baseline. Doesn't mean that you should maybe use this open application model, but I think it exactly does what I tried to explain before, to put the developer in the focus, to say, hey, we are not abstracting away infrastructure, we are abstracting away customer journeys for our developers. And that's basically quite nice that you can combine those components and traits then into this what we tend to call then an application. And for those who know maybe cross-plane, it's basically a very similar concept, right? In cross-plane, this is more called composition and patches, but the idea is of course very similar, right? You have some kind of compositions or components which you can compose to something useful. And the nice idea is that you basically can do this without building your own custom resources, but doing it in a kind of a low-code manner, if you want to call it like this, where you can then easily define those custom resource definitions and can focus on what's really important to understand what's the right abstraction for your developers. And in the end, this is of course Kubernetes resources like deployments and namespaces, or as I said, these custom resources, like for example, sending another or creating another resource in your Kubernetes cluster, which is then taken up by a Strimsy operator, for example, which is the most prominent operator in Kubernetes for Kafka, and which will then create a topic. Right? So you could, of course, directly let the developer create a custom resource for Strimsy, but then again, you miss, kind of the abstraction. Say, okay, I want to have a custom resource definition, which kind of not just says I want to have a Kafka topic, but which says, hey, you want to have obviously kind of a message stream, right? And you don't need to configure all 72 attributes, which you usually need to configure for Kafka topics, but you just say, hey, should it stay there for 1 week? Should it stay there forever? Should we remove it at a certain point of byte size? How important is it? Should we have a lot of replications or not, and stuff like this, right? So abstracting away all these technical details, where you say, okay, usually our developers create Kafka topics with 1 replication or with 12. So obviously there are some which are important, some which are not so important, right? Usually create them with 3 or 8 or 9 or 12 partitions. So we could figure out what are patterns, and we could abstract those patterns away. Yeah. Again, the same topic, right? And you, of course, as I said before, can do the same thing with, just call in a Postgres cluster, for example. Say, okay, whenever you have this custom resource definition now, you can call in a new table or schema in your Kubernetes, in your Postgres cluster. And of course, there's a little bit of orchestration missing in the middle, right, between the cross-plane or kubeflow operator, and of course, creating another resource for streams, or creating a table in a Postgres cluster. And what you can do is you can, for example, use Argo workflows for this, or you can do a kind of any workflow engine out there to ensure that they basically just react to your custom resources, which you define with crossplane or kubeflow, to basically execute whatever you want to do, right? And if you think about this, then it's actually quite nice, because for a developer, you basically now have a clear understanding of the resources which you can create. So they should actually be sufficient for you. They should be on an abstraction level that you directly understand. Okay, I can create a microservice, I can create a stateful microservice, I can maybe just create a Lambda, I can create whatever I need in this use case of this business. And you can then, as a platform team, really kind of gain from, you build a platform for a specific company, right? And that's what AWS and Google and Azure, of course, cannot do. And then you maybe even want to have a backstage, right? Or some kind of other generative tool in the beginning that allows developers to even have a UI to generate those resources, right? And you do this usually by providing templates, right? So you take your pod or backstage, and then you say, hey, you have those 5 templates you can do. You have those 10 parameters for each template, and here we go. And we basically create for you the GitHub repo, and we create for you the infrastructure in the Kubernetes cluster. right? And then, of course, there's a couple of more things you need to take care of, like secrets and CI pipelines and all those things, and the image repo where you push then, the artifacts. But that's basically it, right? That's what you need to kind of have some sort of platform these days. And the most important thing is still the custom resource definition. So don't let you kind of get mad by all those logos which people put on the infrastructure and which people say, hey, this is what I did to build my platform, right? Here lies the real truth, right? If you did a good job in finding this attraction for your developers, the rest is I wouldn't say a walk in the park, but it's feasible, right? This is what you have on this PowerPoint slide is basically probably all you need for a lightweight developer platform, which is good or not good depending how you define the custom resource definition. Okay, so let's quickly sum up to have some time left for question. So I wanted to make and I call this talk platform engineering is not what you think it is, and I'm quite sure that lots of you already knew that I will talk probably about this aspect of platform engineering, but I think it's so important. Platform engineering is not a pure technical thing, and I always find it very funny. I have to admit, if I come to organizations and they tell me, "Yeah, we have a platform engineering team now," and then talk to these guys, and then you figure out, okay, this were the 5 DevOps guy, which before were called the DevOps team. Now they're a platform engineering team. And then, if you think about this, and if we kind of, I think these days all can agree on that platforms are products for developers, so internal products for developers, then you could basically ask the question, would you build a product with 5 engineers, right? No matter how good they are, no offense against developers, and I consider myself as a developer. But if you would go to a startup and say, hey, we're a startup, we build a great product, and we're 7 developers, right? And we say, okay, where's the guy who does marketing, right? Where's she who is the boss of all this, right? Who streamlines things, right? Where's the guy who does the sales, right? Where are the analysts who understand what the customer currently actually needs, right? You cannot build a product with 5 DevOps engineers, and that's my point here. So if you really take it serious and if you want to build a successful platform and not just say, okay, we did a platform engineering team, but it didn't bring too much value because developers are still pissed, everything got more complicated, it's badly documented and Confluent, then you probably focused on the wrong things. And I think in the book, in the team topologies book, they say the simplest platform could just be a very, very useful Confluence page. And they're right? It's if you find a way to explain to a developer in a very easy way how he can spin up a microservice, you should start with that, right? But in many cases you need these abstractions, and if you then do platform engineering, and that's the idea of this term, then it's not only a technical thing, of course. Right? And so the platform engineering is about building products around the right abstractions for your developers. And I think what I realized, that I would say not the hard way, but what was for me the big game changer in this whole picture is to understand that we're way too often doing this still on an infrastructure-centric level. So we way too often, even if we have platform teams these days, we way too often say, hey, here's this, here's this, here's this. Compose your solution out of this, right? But platform engineering is not about composition, it's about abstractions. And if we want to find the right abstractions, we need to think like developers. We need to understand what do developers really want to do, right? And not how is this mapped to our underlying infrastructure. And exactly this translation is done by a good platform team. So it's about building right abstractions for your developers, but don't reinvent the wheel, right? There's a lot out there which already has very good abstractions, application-centric or developer-centric abstractions. For example, the Alibaba Cloud uses exactly what I showed before, the open application model. So they basically follow for their own products this model, this open source model to say, hey, we need to stop this, right? We need to put more focus on saying we want to provide an API which developers understand and not which just kind of abstracts the infrastructure. And that's it from my side. I hope this was useful. If you want to reach out, as I said before, I'm happy to answer some questions now. And you can find the slides behind this QR code. And beside this, I have a couple of announcements to make. Sophia, our head of marketing, asked me up front to again promote or bring to you, I think it doesn't need promotion, but bring to you that we have a YouTube channel on our own these days. So you find all the talks from conferences we organize, but also Brainfood Talks like this one there. So feel free to subscribe it to kind of, also be able to watch those videos in the aftermath. And we, of course, as always, on LinkedIn, and since a few weeks, I think, now on Instagram, right? They find the really really nice content when it comes to what we do in our offices from time to time. So thanks a lot. I hope this was useful. I'm happy to take a few questions now. Okay, there's already one. How discovers different stages like development, pre-prod, and prod? Who is elevating the resources? And that's a fantastic question, right? So how does platform engineering and the overall rollout process play together? I have a strong opinion on this, to be honest. So if you go back to this beautiful platform architecture diagram I showed you before, then I see this exactly here, right? I see this as part of your infrastructure as a code to basically just define which kind of image version you want to have in which stage, right? And it's then you who basically promotes this, right? For me, a modern CI/CD pipeline looks in a way that you basically kind of separate the CI and the CD very heavily, right? I think there's a problem that those things are always used together, but it is different things, right? On every commit, you trigger a continuous integration pipeline. This continuous integration pipeline ends in an image, which is somewhere put in an image repository. And then you basically can configure on your own which kind of tag, which version of this image should go into which stage. And then, of course, the question is, do you duplicate the resources for the stages, or do you have one resource and patch it? I think this is, again, have an experience on this, and I have an opinion on it. I would put all them into a single repository. So let's say you have for each service an own repository where you put them, and then you have patches for each stage. And then you basically, as a developer, need to say, okay, I promote now, image tag version 1 to production, and then you just change the YAML there, and then the the CD pipeline. So in that case, Argo CD or Flux will do the rest and will ensure, as we've seen in this basic image of operators before, that whatever you have here, right, is reflected here. That's the whole idea of Argo CD. And things like pull-based CD tools these days, like Argo or Flux. And that's basically it. That's how I see it. Of course, the promotion in itself needs some kind of, I would say, dark lounging or canary releasing and things like this. This is again where the platform team can help to say, okay, yeah, sure. We, for example, in Open API, an open application model, provide a trait which ensures dark launching or canary releases, so that you don't get all the traffic on the new version, but you kind of get a portion of the traffic in the new version if it's working and it's kind of scaling up. This is something which Kubernetes can do out of the box for you in most cases, right? This is again, as I said, where the platform team helps, but the promotion between different stages should live, from my perspective, in those teams who own the service, and they can configure it then into their resources. Okay, there's another one. I hope this answered your question, Mohammed. If not, then please feel free to raise a second one. How to counter not invented here syndrome when people have to do things themselves in the platform team, but they end up creating something worse than just using the industry standard directly. Yes, we've all been there, and it's of course on the slides it's much easier to explain than in reality, right? I mean that's the crux. How to find the right abstractions and how to build something useful, how to find those 20% which should go into a platform, which are useful then for 80% of the teams, and not those 80, those 20% which hinder 80% of the teams, right? And I think I said it in this sum up slide, and maybe I should give it an own slide, but I strongly believe that this is something you can just ensure if you think like a product, right? And if you also measure your platform as a product, right? we did Net Promoter Score rankings for our internal platforms, so developer platforms. And so we basically asked the teams, hey, would you recommend these platforms to other teams, right? Like you would ask, would you recommend my product to other clients, right? And if they of course say no, I would not do this. And if most of them say no, then you have of course a problem. So two low-hanging fruits or two advices from my side for this. First of all, I would never force somebody to use your platform, right? If your platform is not good enough that people want to use it, yeah, then it's probably a problem of the platform. And the second one is, of course, as I said before, really put the developer in the focus, really talk to them, understand what is value bringing for them. If you use the platform just as another governance tool, it will fail, right? It will fail as helping the developers, and it will also fail as a governance tool, because there will always be some kind of way to do some shadow operations. If you want to do it right, and if you want to really have an impact for the organization, then I think you really need to understand what developers need to actually not end up in what you said in your comment, build something that is more pain than useful, right? And therefore unfortunately not always need to think like a developer. You sometimes just need to think like somebody who builds a product, right? And I think this is a little bit hardwired in our heads of developers, that this is usually hard to overcome, right? Don't say that it's impossible, and there are great people out there who kind of indie developers who build products and develop them themselves. But in most organizations, especially in enterprises, you need people who really put this on their shoulders. And I remember we had a fantastic talk at CodeCrafts a couple of weeks ago, where I'm not sure, the product owner of a platform engineering team, I don't know the company anymore, was there and explained what she does. And it was fantastic. It was really a fantastic talk. She didn't mention a single technical detail, I think, but she basically just ensured how she gets the right information from the right teams. So if you Google for CodeCrafts developer platform, then you find probably a talk from a woman. She was PO of a platform team in a company, and she shared her learnings, and it was really, really useful. Okay, there is a last question which I can take, and then I think we need to finish up. So there was this question of how can you do this in a more, I would say, legacy infrastructure, so not Kubernetes and not operators. And I think that's a good question, because that was not my intention to tell you, hey, you only can achieve this with operators. My intention was just to also give you something tangible, right? So operators and Kubernetes are a great thing to achieve what I tried to convey, to the benefits, right? And you can of course do this with everything else, right? We have had a discussion at the meetup a few weeks ago where they told me that they basically built a platform for years. They didn't even know it, right? But they basically built a platform where you can easily configure your databases which you need. And they did it in a very infrastructure centric, not infrastructure centric, infrastructure as code centric way. And it was very interesting to see that they basically said, okay, we just trust the developers that they put their stuff on Git. And we basically, based on this, ensure that our database cluster or our database clusters are spinned up like this. This was a telco industry. And they basically built their own Argo, right, without knowing it. But they basically built an application which was watching, the Git, the Git repos all the time, and got hooked by Git commits, and then basically just took this, put this into the database clusters, and ensure there is no diff between what they currently have and what they want to have. And then if there was a diff, they basically reconciled it, right? So they followed exactly the same process which Kubernetes does for you, right? And I found this very interesting. So no, this is for sure not limited to technology, right? I think with Kubernetes we have the momentum that we have great tools like Crossplane or Kubevela, which could make your life very, very easy to build up these platforms just in a very limited amount of time. But it's not that you need to have Kubernetes, right? You need to have Kubernetes for nothing, right? You can make customers completely happy without Kubernetes, right? And so it's true for platform teams. You can build great platforms without having Kubernetes, because the greatness of a platform, as I said now a couple of times, is not in the implementation, the technical realization. It's in finding the right abstraction, finding the right products for your development teams in the organization. I think this is exactly on point, and I'm happy because I usually don't realize this. With all this said, I hope it was useful for all of you. If you have any questions or additional questions, feel free to reach out anytime. And yeah, have a great Friday afternoon.